almost see how it did. All right, so now the customer is going to be even more stoked that his cable's clean and it'll test. Cool. All right. 2.5 kV for 1 minute. Testing. Hey, did anybody hear that right off the bat?
That was you? I thought that was like someone else.
No, so this guy here is actually likely evaporation, kind of like sizzling of some of the Dawn power wash copyright. Because when you're pushing 2500 volt, a little bit of anything. All right, what was our passing value?
And the unit is mega right now?
So right now it's mega. Keep it up, buddy. Don't give up. Oh, you gonna break 100? Oh, we broke 100. That's good news. But the problem is, it's still not 100. So, what did we learn? It's better. It didn't have a dielectric breakdown, right? But we were able to actually get at least a better look of what we think we're looking at. So, really, what would the ultimate solution be? Replace. That's good for business. Definitely good for business. And what is the, I guess, more economical for the customer solution? I'd say actually see the cable. And interestingly enough, I sprayed the back end, so I wonder if that might be effective. Because this is a shorter path. So when season for
that 100 mega?
Yeah, 100 mega.
And wouldn't it pass them?
For 15 kV, I don't believe so. 5,000. Yeah, 5,000 for 15 kV. If this is a 1 kV installation, yeah, that would be the difference between passing and failing. Yeah.
Oh, 5,000. Oh, I'm not carrying 3, right?
Yeah.
Okay, so it's 5 million.
So that's the difference between a week ago or 33 years ago.
Would it have made any difference if you wrapped the ribbon around it more?
Yeah, like cover more layers. Yeah, let's do that. I think certainly where the shot is, we're going along here.
Does it matter if you like, if you wrap around 3 times?
I think it would only help.
That's a metal ribbon, right?
Yeah. Alright, let's tie all that together. Alright. Take 2. Test it. Same kind of deal here. In fact, I think my braid has also been soaked by the Dawn power wash, which is now our enemy. That's why we use simple braid. The same kind of deal here. At the very least, these experiments are more memorable when they in fact don't exactly play in. But what we're seeing here is a significant improvement from 16 to, let's say, 100 megahertz. And again, for a 1 kV system, that could make the difference. But not in this case for our example. But we are seeing the guard terminal in action. Take that, Irfan. So how did he show up the guard terminal? Was that interesting? Oh, see? So it's not good. Yeah. Cool. So, but the ultimate solution would be to, of course, don't soak your cable and soak. All right, so 100 points. Yeah, about the same. So I didn't do much difference on here, doing multiple wraps. But the idea that's clearly shown that you can at least subtract some of the unintended path along the outside. And I think, in fact, because it was...
Got inside it.
Yeah. And also the other end, which is a shorter distance here. Why don't I try guarding out this side?
So guarding out different sides or different places could help it better.
Well, it could, because if, say, on the other side of the cable, this is the unintended path. Right? And remembering that the tape shield's also here. I may be subtracting out this unintended path, but there's still this one. If that's the limiting factor, I'm not even canceling that.
Everyone tried to show me one time, they kept saying I was shorting it out when I had the guard on. Does that mean I had to connect it in the same place?
Yeah, I guess so. That your black and your red lead were somehow shorted for whatever reason.
By the guard though, or by?
I don't think, because they're on a separate circuit internally, so I don't know if that's the case.
Yeah.
But you hit a guard terminal shortage, yeah?
It's still, yeah, I kept saying short when I was doing the test that I missed when I was gone.
Hmm.
Kept saying shorted out.
And so,
And every time I applied voltage, it went to 1, or it started and went to 0 right away.
but only when you put the guard. That's it. We're gonna have to recreate that. I'd like to see that. All right, testing. Aha! Lucky guess. So, what's the difference between this guy?
At 200.
And now we very well may be on our way to passing. Only time will tell. The suspense is killing me. I'm telling you. I'm gonna squeeze it.
Oh, you connected the other piece to that?
Yeah. So along the bottom, I also I could use a different braid, whatever, but it was long enough. I also guarded out this end. So my kind of suspicion, I took a lucky guess at it, is that we took care of this one, right? We guarded that out. But look in terms of length, these two are much closer, and like we know air is a good conductor, right? So it's not likely to make a gap, but if that gap is all of a sudden covered in down power wash, right? Then you're bridging this gap, and so this would have been the limiting factor. Now if I guard that out, now we're actually looking, oh, so close.
Did
Yeah.
you
So,
just hit the guard on that end? So that
yeah, I mean, just solely on this end? Yeah, because if that was a limiting factor, sure, but then I wonder, somewhere between 100 megohms and 433, at least we're taking this out of the equation entirely. And so I could clean this up some more. This is kind of I just kind of wrapped it haphazardly to see if that was the issue. But this makes sense that at a shorter distance, this is likely to be the worst, kind of leakage path causing failure. But if I did clean this up some more, tighten my guard protection, I could probably get this to pass. Hey, we're here. That'll be a nice little. Yeah, that'll do. At the same time, even if the water dries in these, it's still leaving kind of the soap particulates. And I can kind of tell because I'm kind of messing with the cable and it's a little slippery here. But yeah, the best solution would be to clean this up with water. To get rid of the soap entirely. But I wonder if cleaning this up just a slight amount more might, just for funsies, get us the pass.
Doesn't matter if it's not.
So I think tighter connections just in general, and in terms of electrical principle would be good. The tight connections are always good. Besides, if there is a kind of path for it to escape to, it will. So I'd say keep it as tight as possible. And we'll see if it made a difference. All right, let's see what that does. 2.5 CDs can do 433, getting there, testing. It's even worse. Let's see what wonder what's going to happen.
Set it down on the table.
What's the matter?
Oh yeah, which might be so fun. By our new enemy, Don Power Wash. Do not like it. Yeah. So then, it's, unless we guarded out the wood table, right? So we change it for-
Just carry it and then you don't touch the copper.
Is it shorting? Is the guard shorting against the copper?
It's short, it's break down.
Y luego tú dices, güey, ¿por qué estás con esto, Martín?
Hey, Robert, is that something we can say?
Cuando la sientes dentro de chico, ¿no? ¿Sabes? Más
Justin.
Maybe especially the place on the right hand side. Oh, you're the left hand side? No, this one.
Oh, yeah, so, oh, okay,
primo de
okay.
Rudy.
Yes, that's actually shorting.
And Ruffle Rose.
Yeah, look at that. Yeah, so actually,
We'll be good in Boston. That was my, that was my.
oh, so you're stealing bonus points.
No, that is smart.
I think, yeah, it's my computer, is it my left hand
I
side,
just
okay. You get the
keep
bonus.
clarifying, I just
You
keep
each
clarifying.
get a half bonus point.
Yeah.
Good
I
team.
just need to clarify, that's all.
So we're gonna.
All right, that's it.
Yep.
Let's see if that did it.
Oh, did it.
Go, gotta go, go.
Now, ooh, we might pass just yet.
All right, here you go.
Ding, 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 ding. You're taking hold. Oh, man, looky there. Well played. Almost done. Oh yeah, 5,000, not 500. All right, 628 megals. If 500 was a passing condition for everyone's KV system. But either way, we've actually pretty effectively been able to demonstrate that the guard terminal does, make a significant difference between the numbers we got. Also, it gave us a good chance to look at our test configuration, not just from here, but then realizing, okay, maybe there's more to it, and actually we had a really good catch at the end that I was inadvertently creating an abnormal condition using the guard, which I intended to be a good thing. So, as long as you kind of understood and read the guard terminal insert there, because that's going to be important for us, and knowing that, should you end up with a NETA company in the Pacific Northwest or in Dallas when Texas freezes over, or you name it, this guard terminal will be a very useful tool for you. Cool. So, take note of these numbers, and again, if nothing else, take a picture with your iPhone 17 Pro 30X Zoom or whatever. So these numbers are going to be useful for you. I guess the green's kind of a not accurate into passing, because 5,000 was our target number. But we'll walk away with that the guard terminal definitely makes a significant degree of improvement, and certainly prevents us from our breakdown condition. Okay? And so what we'll notice basically from the midpoint on, midpoint of the semester on, is that 9 o'clock will be our target time for lab session. Right? And so each of you have I'm going to give this back to that first team, or you can come up. But we have definitely different types of cable to test. But in this case, take your time, operate your machine, right? To consolidate